Hello everyone. Today we'll be discussing about attacking Bluetooth LE design and implementation in mobile and also wearable ecosystem. Before starting with our presentation, I would like to introduce ourselves. I am Ananya and Gowda. I work as a security analyst at Deep Armor. Today, I have with me my colleague Meghana, who also works as a security analyst at Deep Armor. So, coming to Deep Armor, we are a cybersecurity firm based in Bengaluru. So, we have got consulting services and cloud security as our two platforms. Coming to consulting services, we provide secure design and threat modeling, vulnerability assessment and penetration testing, and the third one is certifications and regulatory compliances. So, coming to cloud platforms, we have got our two in-house products, that is Gauntlet and Recon. So let's get into the agenda of our presentation. So we'll be discussing about blueprint of an IoT wearable ecosystem, also challenges faced, in securing these kind of modern day gadgets, also introduction to Bluetooth and BLE security, and finally we will be showing a demo about attacking Bluetooth and BLE networks. So after the demo, we'll be also providing the recommendation for this ecosystem security. With that, we'll be summarizing our presentation. So let's start with our presentation. So as you can see, the first slide is about IoT or wearable ecosystem. So this is how the typical IoT wearable ecosystem looks like. So it has got four components. So as you can see in the picture, there's a backend services that is nothing but a cloud, and there's a smartphone, and there are protocols, and also there's a gateway. These all like four components make up a wearable ecosystem or IoT ecosystem. So let's take an example of home automation system. So coming to home automation system, there will be devices which are called as nodes, and these nodes will be having sensors, and these sensors could be deployed across the house. So what are these sensors going to do? So they would collect informations like temperature, fire alarm, and also fire security alarm. So the same information is sent back to backend services, that is nothing but a cloud, which could be private or public. So you will know most of the examples. Like if I have to talk about cloud, it could be AWS or Microsoft Azure, many more. So the same whatever the information is sent to cloud could be viewed on your smartphones too. So as you can see in the diagram that there are like nodes present and there like gateways are present. So based on the requirement, there can be multiple nodes and multiple gateways, and it is not restricted to like one or two like how we have given. So based on the requirement, you can have your own nodes there. So coming to next slide, here we are mainly, taken fitness trackers as an example, and we have given a case study about them. So everybody would want to, buy us, fitness trackers, like nothing but smartwatches, like it's because the main reason is because they're very comfortable. When I talk about comfortable, it's nothing but they don't have wires around them. That makes it easier and simpler for a user to use them. Also, they're smart enough to take user commands and also give the required output to the user. And also, they're into continuous learning. They keep learning and they keep evolving as the user requirement. So this overall improves the quality of our user. So as I told you in the previous slide that why anyone would want to buy a wearable device, why they would want to use it in the daily life. So now let us talk about the challenges in securing this modern day gadget. So like here we would mainly gonna understand what kind of challenges it's they're facing today's world. So these wearable devices are prone to attacks. Like the many attacks that has been taken place on these kind of wearable devices. So therefore it is very quite challenging to secure these kind of gadgets, mainly because like the traditional STLC frameworks are applied to products which are having a long shelf life with constant requirement. But whereas like these type of gadgets time to market would be very less, and the requirement will be continuously evolving. So that is one of the reason, and one of the main challenge. And the other one would be like there are 30 to 40 protocols, and to choose the right one, by a developer would be very difficult. And the fourth one is like there's not much privacy. And last one would be there's no much research made on IoT security. So there's a like lack of research that is being done. So next, like as we saw, like the challenges in those devices, so there could be even technical challenges. So if I have to take an example of these wearable devices, what contain lots of information. They have lots of data in them. So it could be geolocation information, or it could be biometric data, or it could be sensor data, or it could be payment services. So like it is must for us to secure these kind of gadgets because they have lots of information stored in them. So one of the challenges because these gadgets will be running with limited software stack, which makes it very difficult for us to you know what provide them with asymmetric key cryptos, like because they're heavy on this kind of limited software stack. So because of which the security will obviously get compromised. In the same way, coming to cloud, there could be cross-domain flows or it could be multiple exposure points. Is because of this kind of limitations. So it's along with the hardware part, we need to also protect cloud and mobile applications as well. So coming to today's agenda, so we'll be mainly focusing on two protocols, that is Bluetooth and the other one is BLE. BLE is nothing but Bluetooth Low Energy. So let's get into introduction. So BLE and Bluetooth. So coming to them, there are wireless protocol for short range data exchange. So coming to Bluetooth, it is having a range of 1 to 100 meter, and BLE, which is nothing but Bluetooth Low Energy, is having a range of 10 to 600 meter. So this BLE is a lightweight subset of classic Bluetooth with low power consumption. So these are used where there's less throughput and less power consumption. And also they're having a frequency of range from 2.4 to 2.45 gigahertz. So this BLE, Bluetooth and all are maintained and governed by Bluetooth Special Interest Group. Any updates that are being made is done by the same group. So coming to popular use cases, there could be wearable devices, smart pay system. You can also no, you also heard about Alexa as a famous device which is being used. These are all few of the examples where Bluetooth is being used. So coming to Bluetooth security. So Bluetooth security mainly depends on pairing mechanism, like how they are getting paired, like how the wearable device and the Bluetooth, which is like via phone is getting paired. So let's discuss more on that. So there are like four of them, four methods. First one is JustWorks. Coming to JustWorks, it's very limited and it is having no user interface. And by default, it will have four or six zeros. And the second one is numeric comparison. Coming to numeric comparison, we are having a device with a display which will have yes or no button. When you have to pair your device, you have to type in S, and the third one is passkey entry, wherein you will be provided with six-digit PIN. You have to enter the same PIN in order to pair your device with that of Bluetooth. And the fourth one is out of band, and I can tell this is the most secure one because here the user authentication is being done using other protocols like Wi-Fi Direct or NFC. And once the pairing is done, the network traffic between the two will be encrypted via AES 128 algorithm. So we understood about the pairing mechanism, that is like four of them. And once the pairing is done, the network traffic is being encrypted. So now let us understand more about the weaknesses in this Bluetooth or BLE. So coming to the weaknesses, I just spoke about the pairing algorithm. Simpler the algorithm, you have that we're compromising with our security. So for the first one is the same thing, that is security of the communication link depends on pairing algorithm. So if it's more complex, then the security is also good enough. And the third one is, as I told, just works method will take keys by default, and it will have these four or six zeros, so it will be prone to man in the middle attacks. So also there is key exchange that is taking place between the two during pairing mechanism, so that could lead to eavesdropping. The fourth one, and the most important one, is the apps on the phone. So the more about it we'll be discussing further in our slides.
Thank you, Ananya. Hello, everyone. I'm Meghana Bidrali. I work as security analyst at Deep Armor. As we now understood the problems and weaknesses of Bluetooth IoT ecosystem, let's dive into practical exploitations of BLE system. Here, we are going to attack wearable device with the help of mobile ecosystem. So for today's demo, we'll be using MI Band 2. It is a fitness tracking device, performs activities like sending app notifications, calculating calories, step count, heart rate, sleep rate, etc. Let's see how this device can be breached. And this is the ecosystem overview. Similar to IoT ecosystem, this overview is specific to wearable device. It comprises of wearable device, mobile application, cloud. And here wearable device communicates with its application via Bluetooth, that is BLE protocol. Sometimes wearable device and mobile app communicates with cloud directly using HTTPS protocol. In today's presentation, our main focus is on the communication that is happening between the band and the app. This is how a device communication looks like. We can see that there is lot of data exchange happening from mobile to device and back. So mobile sends information like put device into recovery mode, firmware update, social app notifications, etc. And band sends notifications about user activity data, profile update, and response to social app notifications. So the traffic between the band and its app is encrypted using LTK, that is the long-term key. When attacker is in this vicinity and he's trying to sniff this traffic, then he would be ending up with the garbage data, that is encrypted data. Then where does the problem exactly occur? The problem mainly occurs when we have a malicious application residing on our phone, because whenever encrypted data from wearable device reaches the Bluetooth layer decrypts the encrypted BLE data, which will be forwarded to mobile app to display the actual content in user readable format, just like if encrypted data says some XYZ, and it would be decrypted as calories count is 30. During this data transfer, any app residing on the phone can sniff and fetch all the data that is being exchanged. For this demo, I'll be pairing my MI band with its companion application, that is MI Fit app, which is installed on my smartphone. As an attacker, I'll try to sniff the traffic, steal step counts and calories using DeepArmor's custom malware app. Okay, so let's get started. The white screen here is from Android Studios. It is a logcat window. It displays all the logs on the phone. I've added a filter here to display logs from malware application. And I'm casting my phone using Visor app. We can see that I've installed both MiFit app and BLE malware app. To begin with, uh, I've launched my malware app, which is configured with band's Bluetooth address. Now I'll access this MiFit app, which is paired with my MI band. I'm trying to perform certain activities so that I can add step counts or I can simulate step counts. I'm rotating my hand. I'm performing a few activities. We can see that step counts are getting updated on MI application. And we can also see that it is getting updated on malware app due to data traffic sniffing. So the latest or the last updated value I see is 1026. It is same on Logcat window as well, because Logcat window is capturing the logs from malware app, and it says The step count is 1026 and calories are 30. A quick recap. We paired our MI band to phone, tried sniffing the traffic between phone and the device, where we were able to steal step counts and calories information. This is the GAT profile, and these are the UUIDs, that is Universal Unique IDs, that are responsible for heart rate and step count. And the Universal Unique ID or UUID, that is ending with F9B34FB, is responsible for heart rate, and one that is ending with 00700 is responsible for step count. So, coming to root cause of this issue, the root cause of this issue is any app on Android or iOS that is subscribed to Bluetooth services can read, write, or fetch all the Bluetooth data just like a legitimate app. All that app needs is Bluetooth and Bluetooth admin permission. Bluetooth admin permission is needed to make device discoverable or to find a device that is discoverable. And Android documentation has clearly added this clause that all the apps with these permissions will have this extra feature, but application using it should not misuse this power. And it goes same with the iOS as well, in which we need core Bluetooth framework permission. As we previously discussed, LTK encrypted data gets decrypted on reaching Bluetooth layer, and in order to mitigate this malware attack, we have to encrypt this data with app-specific key at Bluetooth layer, so that only legitimate application can access it. And problem with this trust model is device is trusting entire phone and all the apps on it. And the only solution to this problem is confining the trust boundary. That is, trust boundary should be from device to its companion application or legitimate application. Let's quickly summarize. The next generation IoT device has next generation problem, and entire IoT security comprises of device, phone, communication protocols, and cloud. So all these components has to be included in SDLC process, that is secure development lifecycle process at development phase itself, and continuous security should be included as part of CI/CD pipeline. And today, privacy is of bigger concern. So, privacy, security, and legal has to be woven from the development cycle itself. We also have to consider integration and interoperability problem while finding solution to the existing problems, and make sure the entire IoT security is entire IoT ecosystem is secure. Thank you.